Ever really wondered, what hot and cold really mean? What's the fundamental difference between them beyond just our perception? It's all about how fast molecules move, their kinetic energy, and the intensity of their vibrations. Everything, air, water, your chair, every single object around you, is made of tiny molecules, always in motion, constantly jiggling and bumping into each other. When something is hot, its molecules are zipping around with lots of energy, colliding and vibrating at a rapid pace. Cold? The molecules slow down, moving less and less, their energy diminishing as the temperature drops. So, temperature is just a measure of how fast those molecules are dancing, how vigorously they're vibrating and colliding. Cold isn't a thing by itself, it's just less heat energy, a lower level of molecular activity. But how do we measure this invisible dance? This constant, unseen movement of particles? That's where thermometers come in. A thermometer senses the energy of moving molecules and translates it into a number we can read, giving us a quantifiable measure of the average kinetic energy. Our bodies can feel hot or cold, but thermometers give us precise measurements, allowing for accurate comparisons and scientific analysis. By watching how a substance inside the thermometer changes, we get a reliable reading, a consistent and dependable indication of the thermal state. It's our window into the hidden world of molecular motion, revealing the energetic activity happening all around us. Next time you check the temperature, remember, you're really peeking into a microscopic dance party, a vibrant and energetic display of molecular movement. Pretty cool, right? A fascinating glimpse into the world of physics. Picture a classic glass thermometer with a red or silver line inside. It works thanks to thermal expansion. When liquids get hotter, they expand. When colder, they contract. The liquid, mercury or colored alcohol, sits in a bulb at the bottom and rises up a thin tube as it heats up. The hotter it gets, the higher the liquid climbs, showing the temperature on the scale. When it cools, the liquid contracts and drops down the tube. Those markings on the side, that's your temperature reading. It's a simple, elegant way to see the energy of molecules in action. Watching the liquid move is like watching a physical reaction to the world's heat. No batteries, no screens, just pure physics in a glass tube. That's the story a liquid thermometer tells every time you use it. Science, right in your hand. Liquids aren't the only things that expand with heat. Solids do too. In fact, almost everything expands when it gets warmer, even if it's just by a tiny amount. This principle is ingeniously used in a variety of thermometers. Enter the bimetallic strip thermometer, a testament to the power of material science. It features two different metals bonded together, each meticulously chosen for their unique expansion properties. As it heats up, one metal expands more than the other, creating a differential in their lengths. This difference in expansion causes the strip to bend in a predictable manner, and this bending is cleverly used to move a pointer on a dial, indicating the temperature. No liquid needed, just clever engineering and a deep understanding of how materials behave under different temperatures. Now let's talk about heat you can't see. The fascinating world of infrared radiation. Everything warmer than absolute zero gives off infrared light, even you, radiating heat into your surroundings. Infrared thermometers see this invisible light, allowing for temperature measurements without any physical contact. They work by collecting the infrared radiation emitted from an object with a lens, and then focusing it precisely onto a highly sensitive sensor. The sensor then turns the incoming heat energy into a tiny electrical signal, proportional to the amount of infrared radiation detected. This electrical signal is then processed by a small computer inside the thermometer, which translates it into a temperature reading and displays it on a screen. That's how you get a touch-free forehead reading, quickly and hygienically, or check a pizza oven's heat from a safe distance, ensuring perfectly cooked pizzas every time. From bending metal responding to heat, to harnessing invisible infrared light, thermometers employ a diverse range of clever techniques to accurately measure temperature. It's all based on solid science, but the ingenuity behind these devices often feels like pure magic. So next time you see a thermometer, take a moment to appreciate the clever physics and engineering working silently inside. Measuring heat with such precision and innovation has never been cooler or more fascinating. Modern thermometers often use electronics to measure temperature. A thermistor is a resistor that changes its resistance with temperature. Run electricity through it, and as it heats up, resistance drops. Easy for a computer chip to measure. That's why thermistors are in so many digital thermometers, fast, accurate, and tiny. Then there's the thermocouple, just two different metal wires joined together. Heat the junction, and a tiny voltage appears. directly related to the temperature. Sensitive circuits read this voltage and display the temperature. Thermocouples are tough, measuring everything from freezing cold to blazing hot. Perfect for factories and science labs. Both thermistors and thermocouples turn heat into numbers, making digital thermometers possible. From your kitchen to a jet engine, these sensors keep us safe and informed. The science is invisible, but the results are everywhere. That's the power of digital brains. Thermometers are truly ubiquitous, they're everywhere. From your medicine cabinet all the way to outer space. In medicine, they help us spot fevers and carefully monitor health, using digital or advanced infrared sensors for quick, remarkably accurate readings. Weather stations rely on thermometers to forecast temperatures and warn us promptly about dangerous heat waves or sudden cold snaps. Factories use rugged thermocouples to precisely control ovens, carefully monitor machinery, and ensure consistent product quality. Infrared thermometers check quickly for overheating equipment, all from a safe distance. Even way out in space, thermometers protect satellites and sophisticated telescopes from incredibly extreme temperatures. Without these essential tools, we'd be simply guessing about everything from baking delicious cookies to exploring the vast cosmos. Thermometers keep us safe, efficient, and ever curious. They're silent guardians, always present in our daily lives. Next time you glance at a temperature reading, remember the fascinating science behind it. It's more than just a number, it's a compelling story of energy. The thermometer's story began over 400 years ago with Galileo's thermoscope, a glass bulb that showed temperature changes, but no numbers. In the 1700s, Fahrenheit invented the mercury thermometer and his own temperature scale. Celsius soon followed, using water's freezing and boiling points for a simpler scale. For centuries, liquid and glass thermometers ruled homes and labs. The 20th century brought electronic breakthroughs. Thermistors and thermocouples turned heat into electrical signals. Microprocessors made digital thermometers fast, accurate, and affordable. Now, a tiny chip reads a sensor and instantly displays the temperature. From Galileo's bulb to pocket-sized digital devices, it's a journey of curiosity and invention. Each step made temperature easier to measure and understand. The thermometer's evolution is a story of science changing everyday life. Next time you use one, remember you're holding centuries of discovery. That's progress you can measure. Today, thermometers are smarter, more precise, and more connected than ever before. They're not just for checking if you have a fever anymore. Wearable tech can now track your temperature 24/7, providing continuous monitoring of your body's vital signs. This allows for early detection, alerting you to potential illness before you even feel sick. Imagine getting a notification on your phone that suggests you take it easy, all thanks to a slight temperature change. Smart homes use a network of sensors to keep every room at the perfect temperature, ensuring comfort and energy efficiency throughout your living space. Refrigerators monitor internal temperature, ensuring food safety, and farms use sophisticated networks of sensors to optimize growing conditions, helping them grow more with less resources. The humble thermometer has evolved into a powerful data tool, providing insights we never thought possible. It's shaping health outcomes, enhancing safety protocols, and driving technological innovation across various industries. As sensors become smaller, more affordable, and increasingly connected through the Internet of Things, the vast amounts of temperature data generated will help us understand and solve even bigger, more complex challenges, like climate change. The journey from simple glass tubes filled with mercury to sophisticated smart sensors beautifully illustrates how seemingly simple ideas can have a profound impact, changing the world in unexpected ways. The thermometer's story is a testament to human ingenuity, a story of continuous innovation, highlighting its enduring role as an essential technology, constantly evolving with scientific advancements. So, next time you quickly check the temperature, whether it's on your phone or with a traditional thermometer, take a moment to think about the rich history and the incredible science that lies behind this everyday tool. We're truly living in a golden age for thermometers, with innovations happening at an unprecedented pace. And the future? It's going to be even cooler or perhaps hotter than you can possibly imagine. That's the incredible power of human curiosity and the relentless pursuit of invention.